Good morning, students. Today we will start the chapter correlation. Okay, I have given a note in the previous classes. I hope you all study it. Okay, now to know the correlation, first we have to know the bivariate data. Okay, bivariate data. Now, what is bivariate data? As you can see in the previous semester, we have all calculated or measure all the measurement of statistical data, which all are single variable, consist with single variable, which only one character, the data is collected only for one character. That's why the given all data are single variable, okay, which are called the univariate data. Now if we collect the data for a given assignment, if two data is required, that is data of two character is required, that is we can say the age and height of a person, or the number of students in mathematics and economics. Okay, if two data or more than two data are collected, more than two character data of two character is collected, then these data are called the bivariate data. Okay, so whenever we collect the bivariate data, if two data of two character is collected, then generally we will take one variable as x and second variable is y. Okay, and the collection of data will be represented in the pairwise form xy. So first variable, the values of xy, it is for only in one individual. Okay, this data xy is collected for only one individual. So if there is n observation, that is for there are n observation for which we have to collect the two characters, then the data will be in this form: x1 y1, x2 y2, up to xn yn. So x1 y1 are the data of two character for only one individual. Okay, this is for second individual and this is for n individual. Okay, so in this way we can collect the bivariate data. Now the distribution, this distribution x1 y1 x2 y2 is called the bivariate distribution. So for a bivariate data, the distribution is called the bivariate distribution. Now the next part is, if we take as there are two variable x and y, if we put this value in x-axis and y-axis, corresponding to that is xy plane. Okay, so the x variable corresponding to x-axis and y variable corresponding to y-axis, then if we plot this data in this xy plane, so we will get a following point. Okay, this diagram is called the scatter diagram, okay, or the dot diagram. So whenever every bivariate distribution has a scatter diagram or a dot diagram. Okay, so if this dot diagram is there, there are many form of dot diagram. You can see it in my note which I have given in the previous class. Okay, so from the dot diagram we will see that there will be many type of curve or many type of graph we will found in this form, we will find a new measurement of the given data. So whenever we collect two data x, y, we will find a relation between x and y as age and height. If we collect two data corresponding to two character, age and height, then we can see in generally whenever age is increases, the height of this of that person is increases. Okay, so there is a relation between x and y. So there is a relation between age and height also. So in this way we will find a new measurement which is called the correlation. Okay, so this diagram is scatter diagram. So before what is correlation? So in a bivariate data, if we see that two variables are correlated, that is the change in one values is depend on the or related to the change in other variable or other values, then this characteristic is called the correlation. Okay. Now different type of correlation, there are many form of correlation. That is, if the increases in A whenever x increases, if y increases, then this is called the positively correlated. X and y are positively correlated. If in the change increases in x form, that y is decreases. So whenever the value of x is increases, if the value of y is decreases, then this type of correlation is called negatively correlated. Okay. Now also, if the changes or changes in x and y are linear, that is they whenever x is increases by 3 unit, if we see that y is increases only in 3 unit, then this type of changes is linear changes. So we will call this type of correlation as linearly correlated. Okay, and there is also non-linear correlated. Okay, there is also a non-linear correlation. Okay, so these are the type of correlation. Now measurement of correlation, how to measure the correlation, this is the actual part, or this is important parts. There are two types of measurement of correlation. One is Karl Pearson's product moment correlation. Okay, Pearson's product moment correlation, and second is Spearman rank correlation. Okay. Today we will start with Karl Pearson product moment correlation. So to find the Karl Pearson product moment correlation, first we have to know the variance. Okay, variance of a bivariate data. Variance of a bivariate data. Let's say we have two n variable corresponding to two variables x, y for n observation. Then the data will be in this form: x1, y1, x2, y2 up to xn, yn. Okay, then the covariance variance of bivariate data or covariance of bivariate data, that is it is actually known as the covariance of bivariate data, is defined as covariant of xy and formulated as 1 by n summation x minus x bar into y minus y bar, where x bar is the mean of the variable x and y bar is the mean of y. Okay, so that is why I have suggested to study or revise the previous year chapters. Okay, now you all know, you all can find x bar and y bar, then we will find the corresponding data x minus x bar and y minus y bar and their product, and summing them we will get a result, and dividing by n we will find the covariance of xy. Okay, after that there is the formula for finding the correlation coefficient. Okay, Karl-Pearson moment correlation coefficient is defined as R, or if as the correlation coefficient between x and y, then we will define as xy. So we will define as only R or Rxy, which is equals to covariance of xy divided by sigma x into sigma y. So this sigma x or sigma y are the standard deviation. Sigma x equals to standard deviation of x, sigma y is equals to standard deviation of y. So to find the correlation coefficient, Karl-Pearson product moment correlation coefficient, we have to find the standard deviation of x and standard deviation of y also. Okay, differently. So if we put this formula in calculation method to calculate the given following correlation coefficient, if the given data is available, then by using the formula we will get covariance of xy, as we know, 1 by n x minus x bar y minus y bar divided by sigma x. This formula is summation x square by n minus summation x divided by n whole square into root under summation y square divided by n minus summation y by n its whole square. Okay, so this is the formula we used to know, right? Basically this is root under 1 by n summation x square minus x bar square, right? X bar means x bar equals to summation x by n. So that's why this is formula. This is the given formula. Okay, we will use this formula as the to calculate the correlation coefficient between two variables, right? Now there are many forms to find the correlation coefficient. First, if we calculate this, if we expand this, multiplying and expanding, we will get this type of form type, this type, that is 1 by n summation x y minus x y bar minus x bar y plus x bar y bar, right? Divided by root under, if we take 1 by n square as common, 1 by n square, then we will get this summation x square n into summation x square into summation x whole square into root under 1 by n square. Also from this will give summation x n into summation y square into minus summation y whole square. Okay, now 1 by n summation xy. If we take summation in this individual form, we will get as x bar y bar as a constant number. Okay, for a distribution, x bar is mean of x, which is constant, so we can take out the constant part from the summation. So we will get from this part y bar into summation x bar, summation x, minus this part, from this part x bar into summation y plus summation x bar y bar. Okay, divided by 1 by n square. If we take out 1 by n square from the root, we will get 1 by n from this 1 by n. So 1 by n square root under n into summation x square minus summation x whole square into root under n into summation y square minus summation y whole square. Okay, so now as we know, x bar equals to summation x by n. If we put this, we will get summation xy minus y bar into x bar by n minus x bar equals to summation x by n. So if we find summation, if we have to find summation x, so summation x equals to n into x bar, so it will be multiplied n into x bar into n into y bar plus x bar will be common, y bar will be common, summation 1. Summation 1 mean as there are n observation, so summation 1 will be n. Okay, divided by 1 by n square root under n into x square summation x whole square into root under n into summation y square minus summation y whole square. So if we take this n square in the upper part, so n square by n, which will give only n. Now n summation n into x bar y bar and n into x bar y bar, 1 will be taken out, so we will get n into summation xy minus n into x bar y bar divided by here only n into summation x square minus summation x whole square root under n into summation y square minus summation y whole square. Okay, now just simplifying this, we will get summation xy minus n into x bar means summation x by n summation y by n. Okay, divided by that two part. So after multiplying n, we will get n summation xy minus summation x into summation y divided by root under n into summation x square minus summation x whole square into root under n into summation y square minus summation y whole square. So this is the simplest form to find the correlation coefficient if the given data are given. Okay, if x and y are given, so you see that we can use this formula. Here we have to find x bar y bar. Okay, if we use this formula, we don't have to find the x bar y bar. We can always find from single table xy. If given, we can find the summation x and summation y. Also multiply these two part, we will get the summation of xy. Also we will get summation x square and summation y square, and n is the number of observation. So in this way we can find easily the correlation coefficient from a given data. Okay, so we can use this formula, we can use this formula. Now also we can use another formula, which is R is equals to 1 by n summation x minus x bar y minus y bar divided by root under summation 1 by n summation x square minus summation x bar square into root under 1 by n summation y square minus summation y whole square. Now if we take a variation, if x bar and y bar are integer means whole number, then we can take a variation capital X equals to x minus x bar and capital Y equals to y minus y bar. Then sigma x, that means this part, sigma x will be root under summation x minus x bar whole square summation x square by n root under summation capital X square by n, and sigma y will be summation capital Y square by n. We can simplify this form. Okay, so R equals to 1 by n summation x minus x bar y minus y bar. This will get summation capital X into capital Y, and from this we will get root under summation x square by n into root under summation y square by n. So taking out 1 by n square, okay, from this root under 1 by n, this root under yn, so root under 1 by n into root under 1 by n, we can write 1 by n, and upper there is also 1 by n. So simplifying, we will get summation xy divided by root under summation x square into root under summation y square. So where summation capital X equals to x minus small x minus small x bar, and capital Y equals to small y minus small y bar. Okay, so we can use this formula also if x bar and y bar are integer. So we can take a variation and use this simple formula. Okay, so there are three part. Okay, to find the Karl-Pearson correlation coefficient, you can use any one of these. Okay, that's it for today. I will, in the next class, I will start with the properties of correlation and some problem. Okay, thank you.